And welcome to 3.2 notes on the International System of Units. Remember, we are now in Chapter 3 where we're dealing with taking measurements, including our units, converting between different units, that'll be in 3.3, and then finally dealing with some fundamental units and quantities, density and temperature, and doing some conversions with those. In this section, 3.2, we're dealing with the International System, which is our system of units. It actually goes by the name SI system because it was ratified, this particular set of units that scientists agreed to use was ratified in France, and they call it the Système International. I think that's how they spelled it. But anyway, that's why it's called the SI system, because it's Système International. We say the international system, but it's still called the SI unit or SI system of units. All right, we want to get you acquainted with some of these units. You've heard of many of them before, but I think it'll help since many of us are actually used to the English system. If we say something weighs 100 pounds, you have a certain idea on how much that weighs. If you say that something is about a mile or two away, or if somebody is 6 foot tall, you have an idea on how tall those things are. But when we switch over to the SI system, which is pretty much the metric system, you might not be quite as familiar with that. So in the notes I have a bunch of tables that we got out of our textbook, and I just want to go over some of those, and hopefully it helps in your understanding and getting acquainted with these units. The first thing is the base units. Now we have what are called SI base units because these are the units which many other units are derived from. We're not going to necessarily get into many of those other derived units. Typically those are reserved for physics because of the nature of the study, but there might be a couple that we're going to be dealing with. For example, when we measure length, most of our calculations will be done using meters with a symbol M. When we deal with mass, we're not dealing with pounds, we're dealing with kilograms, or we will often use grams, which is given the symbol G. Temperature will also be fairly different from what you're used to. Here in America, we deal with temperature in Fahrenheit. On the metric system, we deal with the Celsius, which is degrees Celsius, degrees C. But in terms of science, we need to use the Kelvin scale, which is what we call the absolute scale. And notice it is just a K. There's no degree sign with Kelvin because it is an absolute scale. For time, typically we're going to be measuring things in seconds. If it takes longer than that, we will be doing some conversions. And then when we get into a certain amount of substance, which is a counting thing, we won't deal with this until the next course. We'll deal with a mole. The luminous intensity and electric current is generally not things that we get into. Although we might, if for those who do some extra credit next course with electrochemistry, you will be dealing with amps or amperes. But we'll tackle that in the future. You should also be familiar with prefixes. Many of these prefixes you'll be familiar with, but some of them you might not. I'm sure everybody's dealt with kilo, which simply means something is 1,000 times bigger than its base unit. For example, 1 kilogram or kilogram is 1,000 grams. Kilo means 1,000, so 1,000 grams is 1 kilogram or 1 kilogram. Centi is 100. I'm sure you've used that many times. For example, 1 centimeter. Excuse me. 1 centimeter is 100. 100 centimeters. Let me scratch that whole thing out. 100 centimeters equals 1 meter because 100 centi, it's a 100th. A centi is 100th, so you need 100 of them to make your base unit. Milli, I'm sure you're familiar with, as 1,000th. So you have 1,000 milliliters in 1 liter. So those are things that I'm sure you've used before. You've also used the prefix mega, particularly when you're dealing with computer memory. When you're dealing with megs of RAM, you're dealing with megabytes. That's what megs really stands for, megabytes there. And so 1 megabyte is 1,000. 1 million bytes. or it's 1,000 kilobytes, which is typically what people are looking at. But there are some other prefixes that you should know. You should understand deci, micro, nano, and pico. And so to kind of put those things in perspective, let's go down here to table 3.3, where it makes some comparisons that you might be familiar with. For example, 1 kilometer or kilometer is 1,000 meters. Well, how far is that? Well, it's about 5 city blocks, which turns out to be a little more than a half a mile. 0.6, or actually more than 0.6 miles, is a kilometer. If you're dealing with a decimeter, or if we go to a meter is about the height of a doorknob from the ground. All right, so when you open up a door, that's about a meter off the ground, which is about 3 feet. A decimeter, there are 10 decimeters in 1 meter, or actually, I'm sorry, there are 10 decimeters in 1 meter. A decimeter is about the diameter of an orange or of a large apple, depending on the size of the apple, but an orange is a good analogy. When you're dealing with a centimeter is about the size of your shirt button, if that puts things into perspective. Again, there are bigger buttons than others, but that's a good rule of thumb. A millimeter, well, how small is a millimeter? It's about the thickness of a dime. You would have to have 1,000 dimes, which would add up to what? You have 10 dimes and $1, and so it'd be $100 worth of dimes that would add up to a full meter. Now, when you get down to the small scale, really small scale, a micrometer or a micrometer is a millionth of a meter. You're getting down to the diameter of a bacteria cell. The size of a single cell is about a micrometer. And then when you get down into nanometers, they say that it's the thickness of an RNA molecule. That really doesn't help you any, because I mean, what's the thickness of an RNA molecule? We'll be using nanometers when we discuss the wavelengths of light. It's very, very small. It is a billionth of a meter. Now, funny thing is, if you look back to 3.2, they say a nanometer is 1,000 million times smaller than a meter. But they don't use a billion. The reason why they don't use a billion is because million, billions, and trillions have different meanings in different countries, if you can believe it. So they don't use the term billion because that means something different overseas. But it is, a nanometer is a billionth of a meter. It's very, very small. Now, in terms of volume, we'll be oftentimes using liters and milliliters. Now, as it turns out, milliliters and cubic centimeters are the same thing. Now, some of you have heard of the term cubic centimeter before. The abbreviation for it is cm cubed, but what people often say is not the unit, but they'll also abbreviate it cc. So when you're watching medical shows on TV, when they say you need so many cc's of this fluid, they're actually dealing with cubic centimeters, which is the same as 1 milliliter. And a milliliter is about 20 drops of water. I don't know if you understand how many 20 drops would be, but that's about how much a milliliter is. And then in terms of a liter, they say that it's a quart of milk. I don't think that puts, some of you have worked with quarts of milk before, but most of you have bought a 1 liter bottle of pop, or certainly everybody's dealt with 2 liter bottles. Well, cut your 2 liter in half and you have a 1 liter bottle, or it's going to be slightly more than 2 cans of pop or 2 cans of whatever you're buying there. So hope that puts into perspective, what these volumes are. All right, now you're going to become more and more familiar with using them, and so that's what the purpose of lab and class is for, is to help you get acquainted with those units a little bit better. All right. Scrolling down one more, in terms of mass, we tend to use grams in the classroom, but kilograms is oftentimes a unit that we use. Milligrams is also fairly common. We will not deal with micrograms on a regular basis. In general, 1 kilogram is approximately equal to 2 pounds. So if a 100-gram person is about a 200-pound person, just so you know. Anyway, we're almost up with our 10 minutes of time. We'll finish up the 3.2 notes in the next podcast.